Good afternoon to all. Today I will discuss about electric induction furnace. In that particular furnace, once metal high frequency magnetic field we have used to stir the hot metal, and it is also useful for alloying additives, for addition of the different types of alloying elements in that particular furnace, for melting the different metals and different alloy. And also that furnace also is a cleaner method, because in that methods no oxide will be formed in that particular furnace. Actually that melting process has been done in the vacuum places. Due to that thing, no additives or no contaminants, no impurities will be added in that furnace during melting time. And also the sizes ranging from kilogram to tons capacity, the melting capacity. And in that particular furnace, generally we have melted that type of metals: iron, steel, copper, aluminium, and different types of precious metals we have melted in that particular furnace. That furnace is a clean and non-contact process. And because why it is clean and non-contacting process? Because the melting has been done in a vacuum or inert atmosphere. That's why no oxide or no contaminants or no impurities will be added in that particular furnace during melting time. And also vacuum furnace make use of induction heating. Induction heating has been used for melting the different metals in that particular furnace. If we does not take the vacuum position, so what happens? Now the melting iron will be reacted with the oxygen, and due to reaction with oxygen different oxide will be formed, and due to that oxides the quality of the molten metal will be deteriorated. So due to use of vacuum position or inert atmosphere, no oxide will be formed in that particular furnace. And in case of induction heating, what happens? Now here only we use the melting of the conductive materials, because that is electrically conductive materials. And when we keep the metal to the furnace, so here what happens? Now primary winding is there in that particular positions, and we keep the conducting materials in that particular positions. So due to primary winding we have used the copper coils. Okay, due to use of the copper coils inside the furnace or outside the furnace, we use the copper coils. When we provide the AC source to that particular coils, due to that thing the magnetic field will be created. And due to creation of that particular magnetic field, due to continuous creation of the magnetic field in that particular positions, it leads to Joule heating. In that particular furnace. And due to presence of metal scrap, what happens? Due to Joule heating, the temperature will be increased. Due to higher temperature, the metal scrap converted into molten metal in that particular furnace. And due to that induction heating, due to that magnetic field creation, the eddy current will be formed. That eddy current to stir the metal in that particular furnace. That is the main principle and main thing of the electric induction heating process. And due to creation of electric magnetic induction, eddy currents will be generated in that particular positions. Eddy currents will be formed due to magnetic field, and that eddy currents leads to Joule heating. And due to continuous Joule heating, the temperature of that particular furnace will be increased, and due to continuous increase in higher temperature, it leads to start the melting of that particular metal scrap in that particular furnace, electric arc furnace. What happens? Main principle of induction heating based on generally first one electromagnetic induction, and second is Joule heating, means Joule effect. Now, what is electromagnetic induction happens? Now, when energy is transferred, means due to generation of the electromagnetic induction, it leads to eddy currents. Eddy currents will be induced to the conductive materials, means to the conductive metal scrap, and due to generation of the eddy currents, which leads to the Joule effect. So any electrically conductive materials placed in that particular furnace, so due to that particular electromagnetic inductions, it leads to generation of the induced eddy current to that particular metal scrap, and that eddy currents leads to the Joule heating or Joule effect to that particular metal scrap. And last one, that is the second, means Joule heating, also known as ohmic heating, means due to creation of the eddy currents, means resistance will be occurring to that particular flow of the electric current, which leads to eddy current, and that eddy current generates the Joule effect to that particular metal scrap. Okay, and due to creation of that particular eddy currents and resulting the Joule effect, that Joule effect creates the heat, means which leads to generation of the higher temperature. That higher temperature will help to generation of the molten metal in that particular electric arc furnace. So that heat produced to that particular furnace is directly proportional to the square of the current and multiplied by the electrical resistance of that particular wire, means Q, generation of the total heat, directly proportional to I square. I means the flow of the current to that particular wire, and R means the resistance of that particular wire, and T is the flow time of the current. Using that equation, we calculate the total heat, and that induction heating depends upon the generally characteristics of the radio frequency energy that allow the generation of the electromagnetic spectrum below infrared and microwave energy. That leads to that radio frequency energy leads to generation of the electromagnetic spectrum, which is below the infrared and microwave energy. Since to the heat generation of that particular furnace, which will be transferred to the product via electromagnetic waves, means when we send the AC current to that particular coils, which is present as a primary winding to that particular furnace, so due to providing the AC current in that particular copper coils means to the primary winding, it will creates the electromagnetic induction, which creates the electromagnetic inductions, means that is the flux, means electromagnetic induction will be created, and due to electromagnetic conduction to that particular furnace, which leads to generation of the eddy currents, and which eddy currents leads to the flow of the, means resulting creates the Joule effect or Joule heating, which helps to produce the molten metal in that particular furnace. Okay, actually that is a rapid, clean and non-polluting heating, because that melting of that particular using that particular furnace has been done is the inert atmosphere, means vacuum places. So no oxides, no impurities will be added to that particular molten metal. So that's why it is rapid and non-polluting heating. And sometimes due to continuous flow of the electric current to that particular primary winding or copper coils, what happens? Now, higher temperature, higher heat will be generated to that particular winding. Okay, so maybe due to higher heat, the primary winding may be affected. So control of the temperature or heat to the primary winding, we have used the cooled with circulate, means we circulate the water for controlling the temperature to that particular primary winding. Now, what are the features of that particular induction furnace? What happens? Now, that is a furnace requires electric coil to produce the charge. Now, for producing the melting to that particular furnace, we have used the electric coil to the particular furnace. Okay. Then, crucible in which metal will be placed is made of stronger materials that can resist the required heat and electric coil itself. Means here we have used the metal scrap that is electrically conductive. Okay. And also we use the particular materials to the primary winding that also tolerate the withstand the higher heat also. Okay. And that type of materials we have used for winding purpose. Generally we have used the copper materials. What is the advantage of that particular furnace? Then another furnace, reverberatory furnace or cupola furnace. What is that? Now, it is a clean and rapid melting process has been done in that particular furnace, because in that particular furnace we have used the inert atmosphere for melting the molten metal. So any oxygen does not react with the molten metal. So that's why any oxide will not form or any impurities does not mix with that particular molten metal. That is the main advantage than other furnaces. So in that particular furnace we have seen that the design of the electric furnace, they are centered around basic idea. Means what happens now, we have used the copper coils or primary winding or inside the furnace or aside the furnace, and then we position the furnace, and due to that thing the use of copper coils or primary winding, the electromagnetic induction will be generated, and due to that electromagnetic induction which leads to formation of the eddy currents leads to formation of the Joule effect, and due to that thing the metal scrap will be converted into molten metal. So that things will be happen to that particular furnace. So electrical coil will be placed to that particular furnace inside or inside the furnace. Generally to melt it, often the crucible is divided into two different parts. What happens now, in that particular furnace the molten metal will get to the bottom position of that particular furnace, and the slag will be positioned to the upper surface of that molten metal. Means that is the impurities part. Means what happens now, lower section holds the melt into purest form, the metal as the manufacturer desire it, while the higher section of the molten metal the slag will be deposited, and due to position of that slag we will remove easily from that particular molten metal, and in below portion of that particular furnace we have got the purest molten metal in that particular furnace. What are the types of induction furnace? First one is one coreless induction furnace. Means in that particular furnace what happens, the coil, that is the heart of that coreless induction furnace is the coil. That is the main part of the one coreless induction furnace. And what happens now, in that particular furnace we use the copper coil. In the copper coil tubing which is wound into a helical coil. Means here copper tube is there and we wound the coil around that particular copper tubing, and that coil shape is contained with a steel shell, and in that particular coil shape contained with a steel shell which is protected from, because due to coil shape contained within steel shell which prevents the overheating in that particular coils, and also from protection of the overheating we have used also water cooled, means water jacket we have used in that particular primary winding site, okay, for controlling the temperature, because due to continuous AC source current, continuous current will be flow, and due to continuous flow of the current what happens now, higher heat will be generated to that particular primary winding. Sometimes overheating takes place to that particular coils. So for prevention or for protection from the overheating we have used the water cooled system. In that crucible is formed by the ramming a granular refractory, means inside the particular furnace we have used the ramming a granular refractory things we have used inside the coil and a hollow internal, because that refractory granular will help to prevent the higher temperature, means that thing withstands the higher temperature inside the furnace. So that's why we have used the refractory, a granular refractory between the coil and hollow internal. Another thing, the coreless junction furnace is generally used to melt the all grades of steel and iron as well as many non-ferrous metals. Easily we have melted in that particular coreless induction furnace easily. Two-channel induction furnace, what happens in that furnace? A refractory line steel cell which constant the molten metal. Okay, we have used one refractory line steel cell which constant the molten metal, which is attached by a throat. Okay, and is throat which forms the melting component of that furnace. This assembly forms a simple transformer in which the molten metal loops comprises a secondary components. That heat will be generated to that particular furnace. The loop causes the metal to circulate into the main oil of that particular furnace. Okay. Now, the circulation of the molten metal stirring to that particular furnace of that particular molten metal in that particular furnace. The channel induction furnace commonly used for melting the low melting point alloy and also holding superheating to that particular furnace unit also. Okay, what are the different advantages of that particular furnace? First one, higher yield, means the heating will be takes place to the particular inner atmosphere or vacuum position, and due to that thing it is does not form any oxide or any contaminants during melting time in that particular furnace, and also it is a non-polluting and clean melting furnace than other furnace. Okay, faster startup. When we apply the power to that particular furnace, instantly it will start the heating. Okay, and due to heating it will start also melting to that particular furnace. Flexibility. No molten metal is necessary to start the medium frequency coreless induction heating equipment, means no extra molten metal is required for melting the metal. Another is natural stirring, means the assembly in that particular furnace it will take the strong stirring action resulting homogeneous melting in that particular. Due to formation of the eddy current it will take the homogeneous stirring in that particular furnace, and due to that thing the molten metal take homogeneously or mixing homogeneously in that particular furnace. Another, cleaner melting, what I have told, because the melting of the molten metal has been taken to the inner atmosphere, so that's why it is a clean and non-contacting, non-polluting furnace. Another, compact installation, so high melting rates can be obtained from the small furnaces. Okay. Energy conversion, generally here induction melting ranges from 55 to 75%, means overall energy efficiency is higher respect to other furnaces. Okay, and what are the main disadvantages of that particular furnace? Now it is a drawback to furnace use a founder is the lack of refining capacity, means it has no refining capacity in that particular furnace. If we have done or charged materials must be clean of oxide products. If that in that particular furnace some oxygen will be enter to that particular furnace, the oxidation means oxide will be formed in that particular furnace to the molten metal. So generally the all setup of that furnace that is free from oxide formations. Main drawback of the furnace, it has no refining process. Generally, in case of induction R furnace, what happens? High voltage electric source from a primary coil induce a low voltage and generally produces the high current in that particular furnace. And the melting will be takes place in that furnace using a principle of electromagnetic induction. And due to that thing, melting will be takes place in that particular furnace. That is the main chamber of that particular furnace, and in that particular furnace inside refractory lining will takes place. Why we taken that? It will withstand the higher temperature or tolerate the higher temperature, and aside that refractory lining we have used the copper coils. We have connected to the particular AC source. Then we enter the metal scrap to that particular chamber or to the furnace. Inside the furnace we kept the metal scrap. Then we start the power, means AC source we have providing to that particular copper coils, and due to providing the AC source, the electromagnetic induction will be created. Electromagnetic, that type of flux will be created, and due to creation of the electric flux, the eddy currents will be created, and due to generation of the eddy currents will lead to Joule effect, and due to that Joule effect the temperature will be increasing, the metal scrap will be converted to that particular molten metal. Upper side kept the slag, that will be kept through the slag hole, and other molten metal, the purest molten metal kept just bottom position of that particular chamber. So then we will take that through the tap hole.